Hi everybody, this is the Paulys pizza problem, and it's a good example of a high-low problem for a couple reasons. And for some reason I keep screwing up when I do this, and then I transpose things too, which is why I don't do taxes. And first I picked the wrong low, so then I switched it, but I moved over to the other. In any event, when you do this, that the independent variable or the cost driver, okay, is not going to be the dollars, okay. This is the consequence, okay. This is actually this is our result, but we're saying that the number of pizzas drives the cost, okay. So with the high-low method, uses only the highest and lowest observed values of the cost driver within the relevant range. And frequently the high here, like your high cost of production is really 41.6, and that is not the higher cost of the higher number of pizzas. Okay, so you've got to be careful about that, especially because the problems will test you that way. And I can tell you it's real easy to flop from like one column to the next. So I've got a high units. Let's do units first. High units are 15.2. Right? 15.2, okay, is my high units, and my low units, I start out with 86.50, but 8600 is the low, and then check it just for that purpose. For 15.2, my dollars are 41.1, and 8600, my dollars are 28.560. So the difference here is 12,540. Okay, 12,540 in dollars and 6,600 in units. So dollars divided by units gives me $1.90 variable cost. Okay, and once I've got my variable cost, I can take either one of these, the high or the low. I usually take the one with the most zeros, the easiest to subtract. So I took 41.1 minus $1.90 times 15,200 units, okay? So if 41.1 is my total cost, and my fixed cost is, or my variable cost is 28.8, then my fixed cost is 12.2. And that gives us a cost function, okay? So here's our cost function, that my total cost equals 12.2 plus $1.90 x, where x equals the number of pizzas. Okay? What good information would that be for somebody to know? You know, it would be terrific. So that's our total number of pizzas. What's the estimated variable cost in a month in which 9,000 pizzas are produced? It would be 9,000 times $1.90. Okay, 17,100. Because that is my variable cost. And I saved this here for you because that's where I dropped the computer. Would you believe that? I dropped the computer and it typed this in Excel. It's a first for me. Okay. And what's the estimated total fixed cost if 16,000 pizzas are produced, assuming the relevant range remains the same? Fixed is fixed, so it would be 12,200. Gratefully, that's a wonderful thing. And then finally, what is the estimated total cost if 15,000 pizzas are produced, assuming the relevant range remains unchanged? So I would be my fixed cost plus $1.90 times 15,000. You might want to put some brackets around that. I don't actually think you have to anymore, but in my day you did. So I've got a total of 40,700. With any luck, that's right, 12.2 plus 190 times 15,000 pizzas. Okay, if you find anything else here, just be kind to me and let me go sit in a corner someplace because I keep making mistakes. I almost pitched the problem and got a different one. Okay,